Welcome back everybody. This is our sixth class in NEET previous year questions for chapter Current Electricity of class 12th. Before this video, we have made 5 videos in this series and all of those videos are available on our channel in a playlist dedicated to specifically for NEET previous years. We have also started similar playlist or similar series for JEE previous years. So you can go to again our YouTube channel and find those videos out. And if you find these videos useful, helpful, then do press the like button, share them as much as possible, and subscribe to our channel. Also, if you want to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Your even small help will be highly appreciated as it motivates us to keep on bringing these quality videos on regular basis. With this, let's start today's video. And we have, I think, completed around 60, up to 60. So, looks like this was our last question. Okay, we also completed this. This one is also done. This is also completed. Okay, so today we will start with 64th. So 3 resistance PQR and 2 ohm. So actually these are 4 resistance. Okay, so each of 2 ohm and an unknown resistance S in the form of 4th arm of a Wheatstone bridge circuit. When resistance of 6 ohm connected in parallel with S Wheatstone get balanced, what is the value of S? So here we have a Wheatstone. Suppose this is P, this is Q, R, and this is S. And these P, Q, R are of each 2 ohms. So we can say, as per balance principle, that P by Q is equal to R by S. And as P is 2, Q is 2, R is also 2. So S also has to be 2. So S also has to be 2. Only then this bridge will be balanced. And now it is mentioned. Now what we are discussing, when we are discussing about S, then we are discussing combined resistance here. Combined resistance in this part. Now as per question, there is a 6 ohm resistance in parallel with S. So we have a 6 ohm resistance in parallel with S. So combined resistance of S and 6 should be 2 ohms. We can mark it like S dash. So combined resistance of S and 6 is S dash, and dash that should be equal to 2 ohms. So let's find their combined resistance. So 1 by S dash will be equals to 1 by S plus 1 by 6, and as mentioned, it should be S dash should be 2. So it will be 1 by 2. So 1 by S is equal to half minus 6, 3 minus 1, and 2 by 6 or 1 by 3. So 3 ohms will be the right answer. Moving to the next one. In the circuit shown, if a conducting wire is connected between A and B, the current in this wire will be. Now first let's see if the bridge is balanced or not. If bridge is balanced, there will be no current, and if bridge is not balanced, then there will be some current. So to balance, check the balancing. 4 by 1, and on the other side we have 4 by 3. So these are not equal. So this system is not balanced. So what we have to do? First we will find out currents in the upper arm and then in the lower arm, then we will find potential across this 4 ohm resistance and this 3 ohm resistance, and then we will compare the points. So let's suppose this is point P, this is Q, B is already mentioned. So now PAQ, this resistance PA and resistance AQ are in series, so their combined resistance will be 4 plus 4, 8 ohms, and 1 plus 3, these are also in series, so their combined resistance will be 4 ohm. Now we have a battery here of potential V. Now again, these what we can do now, we will find out their equivalent resistance. So their equivalent resistance will be 1 by 8 plus 1 by 4. So 1 by 8 plus 1 by 4, 8, 1, 2, 3 by 8. So this circuit will be equal to a resistance of 8 by 3 ohms with potential V, source potential V. So now current in this circuit, current I, suppose there is current I, so it will be V by 8 by 3, so 8 by 3, 3 will go on the top, so current will be 3V by 8. Now as it is, this circuit is equivalent of this, the right one, the right circuit is equivalent circuit of the left one circuit, and if there is current I, then same current will flow in this circuit. So here we will have also have current I, and value of current I is 3V by 8. Now when this current reaches this point, this is point P and this is point Q from here, P and Q. So when this current I reaches at point P, it will split into two parts. Some will go on the upper part, some will some part in the lower. So suppose upper portion is I1 and lower portion is I2. Now we can divide I in terms of I1 and I2. So I1 will be, as we are finding current in the upper arm, so here current will be, we have to take the second resistance. Here resistance is 8, we have to take second resistance 4, resistance of the opposite arm by total resistance 8 plus 4, 12 into actual current I, that is actual current, that is 3V by 8. So it will be 4, 4, 12, 3 and cancel, so it will be V by 8. And now for I2, as we are taking current for the I2 arm or 4 ohm arm, so we have to take resistance of the opposite arm, so it will be 8 by total resistance 4 plus 8, 12 into actual current 3V by 8. So this will be 2, 3, 3, 2V by 8. So this will be the current in the second arm. So now here we can now we will come back to this diagram, and now we can put values here. Here we have I, and I is equal to 3V by 8. Now in the upper arm, we will have I1, and I1 is equal to V by 8. In the lower arm, we have I2, and I2 is equal to 2V by 8. Now as both of these 4 ohm resistance are in series, so what that means, that when both resistances are in series, so same current flows through them. So in this 4 ohm, I1 is flowing, and in this 4 ohm, there is again I1 is flowing through this. And similarly, in the 1 ohm, there is I2 current, and across 3 ohm, there is also I2 current, because 1 and 3 both are in series. Now what we can do, we know the current through this 4 ohm, we know its resistance, then we can find out its potential. We can find out V potential across this 4 ohm, that will be VAQ. VAQ. So it will be 4 times current, that is V by 8 or V by 2 ampere. Now similarly for the BQ, we can find out VBQ. It will be 3 times the current, so 3 into 2V by 8, or it will be 6V by 8, or let's write it in the form of 8 with equal denominator so that we can compare. It will be 4V by 8. Now, why did we calculated potential for these 4 and 3? Why not 4 and 1? Now, for that, we have to, as per question, we have to find that whether current from A to, if we connect A and B, whether current will flow A to B or B to A. For that, we have to find out potential at point A and potential at point B. And potential is always measured with respect to ground. If you have to measure potential at any point, it will be always measured with respect to ground. And ground of battery, it is always negative part, the negative terminal, sorry. Negative terminal of a battery is always considered is a ground in a circuit where there is only single battery. When we have multiple batteries, then ground can change. But if we have a single battery, then negative terminal of battery is considered as ground. And this negative terminal is connected to point Q. Means all the potentials should be measured with respect to Q. And that's why we measured VAQ and VBQ. Then if we are measuring VAQ, it means we are getting VA. If we are measuring VBQ, it means we are getting VB. So VAQ is equal to VA and VBQ is equal to VB. So now we have the final values. VA is equal to 4V by 8 and VB is equal to 6V by 8. As denominator of both of these values are same, so we can compare easily and we can say VB is greater than A. Means B point is at higher potential as compared to point A. And now if we connect B and A, current always flow from higher potential to lower potential. So current will flow something like this from B to A. Option A will be the right answer. Moving to the next one. For the network shown in the figure, the value of current I. So we have to find value of current I, and as we can see from this diagram, that it is a Weinstein bridge. And is it balanced? 4 by 6, it will be 2 by 3, and these two will also give us 2 by 3. So this circuit is balanced, means we can neglect this 4 ohm resistance, and after neglecting, we have 4 and 2 in the series, so they will combined give us 6, and 6 and 3 in series, so they will combine give us 9. So circuit will be something like this. We'll have a 6 ohm, 4 and 2 combined, and here we have 9 ohm, 6 and 3 combined, and here we have a battery of potential V. Now 6 and 9 in parallel give us LCM will be 18. 3 plus 2, 5 by 18. So combined resistance is 18 by 5 ohm. So current will be potential by resistance. Potential is V. Resistance is 18 by 5. So 5V by 18. Option D will be the right answer. Let's move to next one. In a Wheatstone bridge, all the 4 arms have equal resistance R. If the resistance of the galvanometer arm is also R, equivalent resistance of the combination as seen by the battery. So again, all 4 arms have equal resistance R. So R, 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 and we have a galvanometer here of resistance R. And we have a battery connected. Now, as we can say, all resistances are equal. So what will happen? This will the Weinstein bridge will balance, and if it is balanced, means we can ignore the middle part. And if we ignore the middle part, what we will have? We have R and R in series, so 2R in parallel with again 2R, and 2 two are in parallel with 2R give us R. So final resistance seen by battery is equal to R. Moving to next one. A Wheatstone bridge is used to determine the value of unknown resistance X by adjusting a variable resistance Y as shown in the figure. For the most precise measurement of X, the resistance P and Q. So we know that a Wheatstone bridge is most sensitive when condition 1, all resistances are equal, and second point is that all resistances should be small. Why small? Because smaller the value of resistance, higher will be the current in the circuit, and higher will be the current. Any small deviation in any resistance will cause large fluctuation or large current flow through this galvanometer. So we will see we can say we will find out fluctuations, or we will get fluctuations even if there is a small change in value of resistance. So that's why all resistances need to be equal and they should be very small. So option B should be approximately equal and small will be the right answer. Moving to the next one. The given circuit shows a uniform straight wire XY of 40 centimeter length fixed at both ends. In order to get a zero reading of the galvanometer, the free end J to be placed. So we know that total length is 40, and for this to balance, we know that 8 by resistance of part Xj, resistance from X to J, should be equals to 12 by resistance of Jy. Now as this wire is linear, so its resistance will be proportional to its length. So we just write length here. So 8 by, suppose this is L is equal to 12 by, normally we have a wire of length 100 centimeter, but this is only of up to 40 centimeters, so 40 minus L. This will go on 2 on 3, cross multiplying 80 minus 2L is equal to 3L. So 80 is equal to 5L and L is equal to 16 centimeter. That is option C. Moving to next one. Resistance of wire connected on the left gap of meter bridge is 10 ohm. On the right gap, a point which divides the bridge wire on the ratio 3:2. The length of the resistance wire is 1.5 meter. Then the length of 1 ohm of the resistance wire is. So here bridge wire is divided in ratio 3:2 at the balance point, and the length of the bridge wire is 1.5. So length of one side will be 3 by 3 plus 2, 5, multiply 1.5. So it will be 0.3, 0.9 meter, and length of the second part will be 2 by 5 into 1 by 5, so it will be 0.6 meter, or we can say it is 90 centimeter and it is 60 centimeter. Now suppose resistance of this wire is, we can say, X, and the other resistance is 10 ohm. So we have something like this. Our setup is something like this, that on the left side we have a wire whose resistance is X, and on the right side we have 10 ohm resistance, and we have a jockey here, suppose J A B. So length of AJ is equal to 90 centimeter and length of JB is equal to 60 centimeter. So using these, all these, we can find out value of x. So x by 90 is equal to 10 by 60. So using these, x will be 15 ohm, and the length of 1 ohm resistance of the wire is. Okay, we made a mistake here, silly mistake, that this part, the length of resistance wire, this length is not of Vein bridge wire, it is actually length of this wire whose resistance is taken as x. So we have to change this. Suppose total length of this vein bridge AB is equal to x, then we will add x here, and these all will change. So let me change, sorry for the mistake. Suppose length AB is equal to x, so it will be 3 5x, and it will be 2 by 5 of x. So now according to balancing, this is 3 by 5 of x and this is 2 by 5 of x. Now if we balance, we will get, okay, x we already used, so let's consider it P, resistance P. So now according to balancing, P by 3 by 5 of x is equal to 10 by 2 by 5 of x. 5x get cancelled. This is 5 on gone 5. So again P will be 15 ohm. Now P is equal to 15 ohm. This is the resistance of the wire and length of wire is 1.5 meter. So 1.5 meter length has 15 ohm as a resistance. So we have to find out length of 1 ohm. So we write in inverse. So 15 ohm resistance has length of 1.5 meter and 1 ohm resistance will have a length of 1.5 by 15. This will be 1 into 10 raised to power minus 1 meter. And that is option A will be the right answer. Moving to next one. So meter bridge shown in the balanced position, P by Q is equal to L1 by L2. If now interchange the position of the galvanometer cell, will the vein bridge, if we interchange the position of galvanometer and cell, will the vein bridge work and balance condition will be? So yes, vein bridge will work and balance condition will stay as it is. So it will be again P by Q is equal to L1 by L2, and we just has solved similar type of question in one of our previous video related to this chapter, in which it was asked that if we interchange galvanometer and our potential source, then will that our vein bridge will stay balanced or not. So yes, it will stay balanced, and we have shown in that question that how it will stay balanced. I think if I can find out that question from the starting. So now I don't remember what was the question number, but it was there and I have solved it by making a proper diagram. It is there in the some video. You can find in the some of previous video. It will be there, I remember. So you can watch some of our previous video, and there you will find that. So yes, uh, it will work and balance condition will stay as it is. P by Q is equal to L1 by L2. So option D will be the right answer. Moving to next one. A uniform metal wire of length L has 10 ohm resistance. Now wire is stretched to length twice 2L and now bent to form a perfect circle. Equivalent resistance across an arbitrary diameter of the circle. So initially length was L and resistance was 10 ohm. Now length becomes 2L. Assuming volume stay constant, so resistance will becomes N square times original resistance, where N is the multiplicative ratio. As length is become twice, so N is equal to 2. So resistance is 2 times of the original resistance, 2 square times. So it will be 40 ohms. Now we make a circle of it. So suppose now we made a circle of this whole wire, and we have to find out resistance between two diametrically opposite points. So suppose this is A and this is B. Now as total resistance of this circle is 40 ohm because it is made of a wire which has resistance 40 ohm. Now half of it is in the upper side and half of it is in lower side. So upper half will have 20 ohm resistance and the lower half will also have 20 ohm resistance. Now we have 20 ohm and 20 ohm in parallel. So their parallel combination will give us 10 ohm of resistance. Moving to the next one. Wire of length L and resistance 100 ohm divided into 10 equal parts. So divided in 10 equal parts means each part will have 10 ohm resistance. First 5 parts are connected in series. So first 5 in series will give us 50 ohm. These are 4 and 5 in series, and next 5 in parallel. So next 5 in parallel, as value of each one is 10, so their combined resistance will be 10 by 5 and it will give us 2 ohms, the resistance of the final combination. So from the series we will get 50 and from the parallel we get 2, so 50 plus 2, 50 ohm will be the final resistance. 10 resistors each of resistance are connected in series to battery of EMF E and negligible resistance, internal resistance. Then those are connected in parallel in the same battery, the current increase n times the value of n. So first internal resistance is negligible. So we have can say a battery with 10 resistance of value R in series. So their final resistance will be 10R and current in this series circuit will be E by 10R. Now 10 resistance in parallel of value R, so that they will give us total resistance of R by 10 in parallel, because what we will get 1 by R plus 1 by R plus 1 by R when in parallel, and this will be 10, so 10 by R or inverse R by 10. And here current I parallel will be E times R by 10 or 10 E by R, and their ratio IS by IP will be E by 10R into 10E by R. R get cancelled, E get cancelled, that is 1 by 100. So in case of parallel, current is 100 times of the series. Option D will be the right answer. Effective resistance of a parallel connection that consists of 4 wires of equal length, equal area, cross section, same material is 0.25 ohms. What will be the effective resistance if they are connected in series? So let's consider there are 4 wire, and as their length is equal, area is equal, cross section is equal, material is same. So suppose their resistance is R. So if 4 wires of equal resistance are connected in parallel, their effective resistance is R by 4, and R by 4 is mentioned as 0.25. So from this R is equal to 1 ohm, and if they are connected in series, so 4 1 ohm wires connected in series will give us 4 ohm. Next one, equivalent resistance between A and B. So we have to find between resistance A and B. Let's suppose we have a point C here and D and E. Now we can see that DC and CE are in series, so their combined resistance will be 8 plus 4, 12 ohm, and this 12 ohm will be in parallel with 6 ohm. So circuit will look like this. Four, 8, 6, and here we have 12 ohm resistance. 8 plus 4, 12. Now this 6 and 12 in parallel, so they will give us 12, 1, 2, 3 by 12, 1 by 4. So these will give us 4 ohm. So circuit will look like this. 4, 4, 8. So 4. 4 plus 4, 8 plus 8, 16. Option B will be the final answer. Moving to the next one. In the circuit shown below, the reading of the voltmeter and ammeters will be. So as we can see, source is equal in both of these, that is 10 volts, and in the first one, voltmeter is connected across 10 ohm resistance, and in the second one, voltmeter V2 is connected across 10 ohm resistance but with additional 10 ohm resistance. Here we have only resistance of a voltmeter, and here we have additional 10 ohm resistance, and now we have currents I1, I2 and A1, A2. Now in this type of question, we don't know that whether we have to consider these voltmeters and ammeters as ideal or as a practical scenario. So what we will do, we will solve for both of the cases and then find out that which out of which the answer matches. Let's start for ideal case. Now in case of ideal, voltmeter has infinite resistance. For a voltmeter we have infinite resistance, and for a ammeter we have zero resistance. So if resistance of voltmeter is infinite, there will be no current flowing through this path, as resistance of voltmeter is infinite, and similarly resistance of this voltmeter is also infinite, so there will be no current in this path. So in case of upper one, actual current will flow through this one to 10 ohm, and in the lower one also all the current will flow through this 10 ohm resistance. As source is same and effective resistance is same in both of the cases, so current will be same. So in ideal case, I1 is equal to I2, and as both voltmeters are ideal, they will measure equally, and this 10 ohm resistance will not play any role here because already its resistance is infinite. So V1 is equal to V2. That's for ideal case. Now coming to the real scenario, practical case. So in case of practical, let's first clean this. Now practically voltmeter has very high resistance, but that's not infinite, and higher the resistance of the voltmeter, higher the value it measures. So as we know that this voltmeter, assuming that both of these voltmeters are identical, this voltmeter has additional 10 ohm resistance with it, and so effectively this voltmeter has higher resistance as compared to V1, and it has higher resistance mean it will measure higher value. So for practical case, V2 will be greater than V1, and as this resistance of this lower path is higher, so more current will flow through this part, and in this case comparatively to V2, resistance of V1 is smaller, so there will be more current flowing through this. And what we can do now, we have to take parallel combination. Parallel combination of this circuit will be, suppose resistance of voltmeter is X, so combined resistance of this circuit will be 1 by 10 plus 1 by X, and combined resistance of this circuit will be 1 by 10 plus x of 1 by 10. Now we solve it. It is 10x. It will be 10 plus x, and it will be x plus 10 into 10, x plus 10 plus 10. So final resistance of this circuit will be, it will be 10 times x plus 10 divided by x plus 20, and final resistance of this circuit will be 10 times x divided by x plus 10. Now it's not easy to compare that whether these will equal or not, or we can say we assume that these are not equal as expression of both of them are different. So as they are not equal, so their currents will also be different, and so we at least we can say I1 is not equal to I2 in practical case. We don't know which one will be the higher, which one will be the smaller, but we can say they both are not equal. And if we we can say compare these two options with available options, we get that for ideal case our answer matches with option B, and for practical case we get V2 is equal to greater than V1, but getting this part we are not sure whether it will happen or not. So we will go with option B. Moving to the next one, the reading of ideal voltmeter in the circuit. So for that, again, as we have already solved this type of question, what we have to do here, we have to find out potential difference between the 2 points to which voltmeter is connected. So suppose this is point A, this is B, this is C, and this is D. So we have to find out potential difference between C and D. For that, what we will do, initially we assume that there is no voltmeter connected, and ideally this voltmeter has infinite resistance, so there will be no current flowing like from top to bottom or bottom to top from between C and D point. So first we will calculate current through this upper arm, then through the lower arm, and then we will multiply that current to 30, then to current to 20, and then we will find the potential difference. So first let's draw the diagram. Assume there is no voltmeter connected, so we have 20 and 30 in series, and here 30 and 20 in series, 30 20 20 30. Now these are in series, so they will effectively 20 plus 30 50, 30 plus 20 50, and 50 and 50 in parallel give us 25 ohm resistance, and we have a 2-volt battery here. So current in the circuit will be 2 by 25, or we can say it 4 by 50 or 8 by 100. Why we write it like that, 8 by 100? So our calculations become easy. So here current will be 8 by 100. So again here incoming current should be 8 by 100. As total resistance of upper arm and total resistance of lower arm are equal, so current will be divided equally. So in the upper arm we will have 4 by 100 ohm, and in the lower arm we will again have 4 by 100 ohm. Now we have to find out potential difference across 30 ohm. Current through upper arm is 4 by 100, so potential difference developed across 30 ohm resistance will be current times resistance. So 4 by 30 into 4 by 100 into 30, current into potential, that will be 1.2 volts. That is for upper arm. For the lower arm, current is same, 4 by 100, only resistance is different, that is will be 0.8 volts. So point C is at 1.2 volts potential, and point D is at 0.8 volt potential. Difference is 1.2 minus 1.08. So option D, 0.4 volt will be the final answer. Moving to the next one. two metal wires of identical dimensions are connected in series, sigma 1, sigma 2, their conductivities of metal wire respectively, identical dimensions, so their length is same, area is same, effective conductivity. So we can say that when we combine both of these wire in series, so they will act as a single resistor. So we can say their total resistance is RT is equal to R1 plus R2. Now we know R is equal to rho L upon A, where rho is resistivity and it can be written as 1 by sigma, that is conductivity, into length by A. So total resistance will be also written as 1 by sigma total by, now as there are two wires, so their combined length will be 2L by area stay the same. For R1 we have 1 by sigma 1 length by area, and for R2 we have 1 by sigma 2 length by area. Length by area get cancelled in both of these, so we have 1 by sigma 2t is equal to 1 by sigma 1 plus 1 by sigma 2. What we take now, we can take LCM, so 2 by sigma t is equal to sigma 1 sigma 2 divided by sigma 1 plus sigma 2, and from this sigma t is equal to twice of sigma 1 sigma 2 divided by sigma 1 plus sigma 2. So option A will be the right answer. And we have taken here length 2L because when we combine them then and consider it as a single wire, then length becomes L plus L, 2L. Let's move to the next one. A, B, C are voltmeters of resistance R. So these are not ideal voltmeters. 1.5R and 3R. So R, 1.5R, 3R. As shown in the figure, when some potential difference applied across X and Y, the voltmeter readings VA, VB and VC will be equals to. So these are the voltmeters with certain resistances. Now what will happen? The voltmeter measures the value of its own across its own resistance. We can say if a voltmeter has a resistance, suppose we can say if it has a resistance R, then it will measure value equal to potential difference developed across a resistance with some current I flowing through it. So the value of a voltmeter with resistance R is equal to potential developed across a resistance of R with some current I flowing through it. So what we will do, first we will find out the value of current in this circuit, and then we will multiply that value of current to their respective resistances, and we will be able to find out we can say potential developed across them. So suppose there is current I flowing in the circuit. There is current flowing I flowing from X to Y. Now, so the voltmeter A measures value I times R. Now coming to B and C, this current I will split into two parts, and IB will be equal to resistance of the value of the opposite resistance, that is 3R divided by total 3R plus 1.5 that is 4.5R into actual current, that is I. So R get cancelled and we have 30 by 45, so it will be twice 2 by third of I. So VB equal to 2 by 3 of I multiplied by resistance, that is 1.5 over 15 by 10 of R. So 3, 2 and get cancelled. So it will again also measure IR. So VA is equal to VB. Now coming to IC. IC will be 1.5 R divided by 4.5 R. We are calculating current for C, that is IC. So we have to take the opposite resistance 1.5 R by total into total current, that is I. So it will be 1 by 3 of I, and now we can say VC will be current into I by 3 into its resistance, that is 3R, and using this what we get again IR. So all of these voltmeters will give us equal value. So option A is the right answer. Moving to the next one. So two rods are joined together to end as shown. Both have cross section, equal cross section. Length is equal. Resistivity of copper and iron is mentioned. How much voltage is required to produce a current of 1 ampere? So what we have to do? We have to find out their resistance, their combined series resistance, and then we will multiply it to current, and then we will get the value of voltage. So first, coming to the copper, resistance of copper will be resistivity of copper, that is 1.7 into 10 raised to power minus 6 into length is 1 by area, it is 0.1 centimeter square, or we can say 1 into 10 raised to power minus 2 centimeter square, or into 10 raised to power minus 4 meter square. So 1 into 10 raised to power minus 6 meter square. So resistance of copper is 1.7 ohm, and for iron it will be 10 into minus 5 length by area, so it will be 10 ohm. Yes, I think, yes, 10 ohm. Okay, sorry, wait a minute, we made a mistake. These are in ohm centimeters. So our length and area has to be in centimeters. Area is in already in centimeters, so let's revert it back. Area will keep in centimeter. Length is in meter. Resistivity is in ohm centimeter, so we will take length in centimeter, and area is already in centimeter, so it is 1 into 10 raised to power minus 2. So 1 into 10 raised to power minus 2, it will go on the top, so it will 10 raised to power 4, 1.7 into 10 raised to power minus 2 ohms for the copper, and for iron it is 10 raised to power minus 5 into 100 by 10 raised to power minus 2, it is 10 raised to power minus 1, or we can say 1 into 10 raised to power minus 2. 10 into 10 raised to power minus 2, sorry. So combined resistance will be in series are total 11.7 into 10 raised to power minus 2, or we can say 0.117 ohm in series. Now current is mentioned as 1 ampere, so voltage will be I times R, that will be 0.117 volts. Option D will be the right answer. Moving to the next one. So a 12 centimeter wire have a shape of a right angle triangle having side 3, 4 and 5 shown in the figure. The respective sides are measured one by one in multimeter. Resistance will be in the ratio. So we have to find out resistance between the sides. Now in this question, we don't have the total value of resistance of the wire. So what we do, we assume a resistance per unit length. Resistance per unit length is equal to X. So AB wire will have 3X resistance, BC will have 4X, and AC will have 5X. So this will be 3X, 4X, and 5X. A, B, C. Now let's find resistance between A and B. So for AB. Now for AB we have two paths. Either we can go from A to B directly, or we can go via A to C and then C to B. And for that, AC and CB, AC and CB are in series. So we will have something like this, that this is 3x and 5 plus 4, this we have 9x. So between A and B, we have two paths, A to B 3x direct and 9x via C. And their parallel combination will give us RAB is equal to 1 by 3x plus 1 by 9x. It will give us 9x by 4. Now for, we can say AC. For AC, we have 5x directly and 4 plus 3 plus 4 in series. So 5x and 7x in parallel, and their combination, it will look like something this: 5x and 4 plus 3, 7x. Here we have A and here we have C, and their final combination will give us RAC. It will be equal to 35x by 12. And similarly, we can find out resistance for RBC, and it will come out to be 8x by 3, and their ratio AB by BC. So first we will write AB. AB is 9x by 4. Ratio BC is 8x3, and CA 35x12. So to find the ratio, what we have to do, we have to make the denominator equal. So what we do, we multiply it by 3 and multiply it by 4. So this will be 27x. So 27 ratio 32 ratio 35. Option B will be the right answer. Next one, a uniform wire, cross section A, length L, resistance R into complete circle, resistance between two diametrically opposite points. So wire had resistance R. Now if we bend it to make a circle, what we will have, suppose these are two diametrically opposite point A and B. So we have half wire on the top, half wire on the bottom. Resistance of the upper half is R by 2, for the lower half it is R by 2. And now if we have two resistance of value R by 2 in parallel, their combined resistance comes out to be R by 4. Next one, 5 equal resistance are connected, shown in the figure. So 3 and 2, 5. Battery of potential V connected between A and B. So here we have a battery. So current flowing we have to find out between A, F, C, E, B. Where A, F, C, E, B. So we have to find out this current. Now, as we can redraw this diagram slightly. Let me redraw it. So this is R, 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 C, D, E. Now this B point, we take it outside, and these two resistance and point F, we also take them outside like this. This is point F, and these are again R, R, and this F is connected to battery. So this is connected to battery, something like this. And now if you see it, this is a vein bridge, and bridge is balanced, so there will be no current in this part, so we can ignore this one. So let's ignore it. Now we have to find current AFC. So this is A, this is B, AFC EB. So we have to find current in upper arm. Now R and R in series, again R and R in series. So 2R in parallel with 2R, effective resistance will be R. So current in this whole value of current I will be, if potential is V, so V by R. And as resistance of upper and lower arms are equal, so current will be divided equally. So current in the upper arm will be V by 2R, in lower arm also V by 2R. Option C will be the right answer. Now moving to the last one, current we have to find out. And as we can see, this resistance and this are in parallel series, sorry. So 6 plus 6, 12 in parallel with 3. So 1 by 3 plus 1 by 12, 12, 4, 1, 5 by 12, or total resistance will be 12 by 5. And now we have to find out current. So current will be V by R. V is 4.8 by 12 into 5. It will go 0.4 into 5 is equal to 2 ampere. So option B will be the right answer. And with this, we end this video here. With this, our chapter is also finished. Hopefully this video will be helpful to you. Again, you have any doubts, suggestion, or anything, you put them comment section. I will try to implement or improve. If you like this video, do press the like button, share as much as possible. Also, if you like to support us financially, you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any amount will be highly appreciated. So with this, again, thanks for watching, and we will meet in next video with next chapter.